March 23, 2005. Texas City, Texas. 1:20 in the afternoon. A routine refinery startup turned catastrophic. 15 workers died instantly. 180 more were injured, all because a single tower overfilled. A geyser of flammable liquid shot into the sky. A vapor cloud ignited. This was not an accident. This was preventable. The BP Texas City Refinery was the third largest in the United States. It processed nearly 500,000 barrels of crude oil every single day. The isomerization unit, ISOM, took low-octane hydrocarbons and turned them into high-octane blending components for gasoline. At the heart of that unit sat the Raffinate splitter tower, a 170-foot-tall distillation column. Under normal conditions, liquid raffinate flowed in, separated, and excess was drawn off to storage. Level controls, pressure relief valves, and a blowdown system kept everything safe. But reality looked very different. The plant had been through an Amoco-BP merger years earlier. Cost-cutting left equipment aging and procedures outdated. Temporary contractor trailers sat just 120 feet from the blowdown drum. No one saw the hidden risks building. Startup began early that morning after a maintenance outage. Operators began filling the Raffinate splitter tower. The level transmitter was faulty. It kept showing a low reading even as the tower filled. No liquid was drawn off to storage. For over 3 hours, they kept pumping feed. Alarms sounded repeatedly. By early afternoon, the tower was dangerously overfilled and overheating. Hot liquid spilled into the overhead line. Pressure climbed rapidly. At 1:14 p.m., the 3 relief valves opened. Over 50,000 gallons of flammable raffinate poured into the antiquated blowdown drum. The drum and stack filled fast. A radio call reported hydrocarbons overflowing from the vent. The crew had no time to react. At 1:20 p.m., the blowdown stack erupted. A geyser of hot flammable liquid shot 100 feet into the air. It rained down across the unit. A massive vapor cloud formed at ground level. Then ignition. The first explosion shook the ground. A second. A third. Fireballs rolled through the ISOM unit. The trailers closest to the stack were obliterated. 15 workers inside never had a chance. The U.S. Chemical Safety Board investigation exposed 3 deadly layers of failure. First, equipment failure. The level transmitter gave false readings. The blowdown drum and stack were an obsolete 1950s design that vented straight to atmosphere. No flare, no containment. Pressure relief systems were never modernized. Second, human error. Fatigued operators had worked 12-hour shifts for 30 straight days. Startup procedures were unclear and not followed. Critical alarms were ignored under production pressure. Third, management failure. BP's safety culture was broken. After the Amoco merger, cost-cutting starved maintenance and training. Process safety management under 29 CFR 1910.119 was systematically ignored. Mechanical integrity, operating procedures, management of change, all failed. Near misses were dismissed. Personal injury rates looked good, so leadership believed the plant was safe. The independent Baker panel confirmed it. BP had no effective process safety culture across its U.S. refineries. 5 lessons every OSHA 10, 30, and 500 or 510 student, every safety professional, must live by. 1. Never trust instrumentation without verification. Cross-check level transmitters and alarms before every startup. It's 29 CFR 1910.119 mechanical integrity in action. 2. Fatigue kills process safety. Limit consecutive shifts. Exhausted crews miss warnings. 3. Blowdown systems that vent to air are unacceptable. Demand inherently safer designs. Flares or closed relief systems, no exceptions. 4. Temporary structures have no place near process hazards. Trailer siting must follow blast radius analysis, not convenience. 5. Personal safety metrics never replace process safety. Good injury rates hid catastrophic risks. Track leading indicators like near misses and overdue maintenance. Leadership must own 29 CFR 1910.119 or history repeats. 15 workers never made it home that day. Their names remind us that safety failures have faces. The BP Texas City disaster did not happen because one gauge broke. It happened because an entire safety culture failed. In refineries, construction sites, or any high-hazard workplace, safety is not a checkbox. It is a daily decision. What is one lesson from Texas City you will apply on your next shift? Drop it in the comments below. If this breakdown helped you understand real OSHA process safety failures, hit like, subscribe to HSEstudy, and turn on notifications. Next week, we decode another U.S. industrial disaster that changed the rules forever. Stay vigilant. Stay safe.